We've made it to the exercises. So here we go. Start. It says use this one. What percentage of bike rides happen in January? So we need to get the month, and you can press Shift Tab Tab. 1 is January. So we test it whether it equals 1. And then we can do dot mean. This is a Boolean series. And we see that about 2.7% were in January. What percentage of bike rides happen on the weekend? Okay, this is a little bit more challenging. So do dot dt. And we can say dot, not week, weekday. All right, so if we do Shift Tab Tab, we'll see that, okay, Monday is 0. So we want this to be either 5 or 6. So we can say, is it greater than or equal to 5? That will test whether or not it's on a weekend. Saturday is 5, Sunday is 6. And we can do dot mean, so almost 20%. What percentage of bike rides happen on the last day of the month? Okay, this is, sound like it'd be difficult, but there is this is month end. This is a attribute. This is an attribute. So again, we just do what percent. We do dot mean again. So about 3%. That makes sense. So 1 out of 30 days is approximately 3%. All right, number 4. We would expect that the value of the minutes recorded for each writing is approximately random. Can you show some data that confirms or rejects this? So here's the start. We want to see, like, is this random? Are people, I would guess that this should be random, a random number between, you can have a 0 here, between 0 and 59, right? Would there be any reason why riders would pick up a bike like closer to the hour, maybe? So that's perhaps possible. So what we can do here is get the minutes as, you can get these minutes. And one thing we can do is we can call value counts on this. And we can see this, what is the most common minute? So the most common minute is 12. So there's 900 rides over here that are 12. And the least common minute is 26. So there is a big difference between the least common. It's actually not a huge difference. But that's sort of what you would expect if you just have, just do random number calculations. Is probably what you would expect for the, highest and least number. Of course, you can do some formal statistical testing to determine if this is truly random. Maybe there's, some shenanigans going on with this City of Chicago bike data set, and the city is, purposely adding minutes or something and, rounding things up to the nearest minute or something. So this is sort of some interesting analysis you can do here. I think would expect randomness here. So anyways, it looks like it's pretty random. Doesn't look like anything is egregious. Like no number is well above the, the mean or the median, the average appearance. But, to formally test this, you need some sort of statistical test for randomness. All right, number 5, aside the ride length, the length of the ride to ride length. So we've already done that. Then find the percentage of rides that lasted longer than 30 minutes. So how do we say, is it longer than 30 minutes? This is where we can get that total dt dot total seconds. And so this is like the total length of the ride. And it's good to use total seconds to incorporate any rides that lasted longer than 1 day. There were none over here. And then we need to test this that are longer than 30 minutes. So 1800 seconds, right? So 30 minutes times 60 seconds per minute. So we'll see how many of these were longer than 30 minutes. And then we can do dot mean over here. So actually very few of them, only around 2% were longer than 30 minutes. Okay, so that is it for the exercises.